Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the problem of LeetCode furthest building you can reach of index number 1642, and the problem is of one of the medium type problems of LeetCode. Okay, so before proceeding further in this problem, I just want to make it clear that this problem is going to be very much interesting. How this is going to be very much interesting? Because since I have solved this problem, I have just think about various approaches to solve this problem. You can use a binary search, you can use a heap type data structure, or you can say a priority queue, or you can use a multiset, something like that. Okay, so rather than going much into deep into those concepts, let us try to first understand what this problem is going to signify. Okay, so we have been given an integer array of heights, that is an array that is going to denote some heights. Okay, representing the heights of buildings, some bricks and some ladders. Okay, and we are going to start our journey from building 0. Journey starting from building 0. Okay, this one, and move to the next building by possibly using bricks or ladders. Okay, so there will be given some amount of bricks and some amount of ladders, and we are going to use by moving we are going to use such amount of bricks or ladders to move to the next building if possible. Okay, while moving from building I to building I plus 1, and note that the array of heights is going to be using a zero based indexing. If the current building height is going to be like greater than or equal to the next building height, then we can easily jump from that building to the next building. That is, suppose if you are at this building, then you can easily jump to the next building because this height is going to be like greater than or equal to the building with next one. Okay, the height of the next building. Okay, if the current building's height is going to be like less than the next building heights, then you can either use one ladder or this amount of bricks. Okay, so like if you want to jump from this building to the next building, then either you can use one ladder to directly go to the next building, or use some bricks to just increase the height of my current building. Okay, and the amount of bricks that is needed is like h of I plus 1 minus h of I. That is the difference between the heights of the next building and my current building. Okay, and we have to return the furthest building. Zero based indexing is used that we can reach if we are going to use ladders and bricks optimally. Okay, so we are going to use ladders and bricks and check it out. What is the maximum index I that we can go considering array of heights as the zero based indexing, and maximum distance, or you can say maximum index I that we are going to go using the given ladders and bricks if needed to jump from my current building to the next building. Okay. So there are the examples that is given to us. Let's talk about the constraints. It is going to help us. Okay. So the array length is going to be like 10 power 5. So O of n square approach is going to fail completely. So we should think for O of n log n or O of n if possible. And heights of I is going to be like 10 power 6. And bricks is going to be like 10 power 9. And ladders is going to be like up to heights dot length. Okay, so let us try to understand this problem with the help of examples. Then we will together find it out what should be the best solution of this problem. Okay, so let's come on. Okay, so basically you can see here I have taken an array of the size, I don't know what is the size. Okay, so let us try to just to make some buildings. It should be like first one should be of 4 feet and the next one would be of 12. So you can easily jump from this building to this building. No, you cannot jump. Okay, so we are going to use some ladders, or that is you are going to either one ladder or you are going to use some bricks. And if you are going to use some bricks, what will the number of bricks that I am going to need? I am going to need around 12 minus 4 bricks to increase this height. Okay, so let us try to make some more buildings. And next building would be like of height 2. So I don't think this is going to be height 2. I can easily jump from this building to this building because its height difference is going to be like negative for the forward minus backward. That is current building heights, that is this building height minus this building heights. Okay, so you can easily jump from next building if my current heights building is going to be like greater than or equal to the next heights building. Okay, so next one 7, you can easily jump from this one to this one. No, you cannot easily jump. You can use either a ladder or you're going to use some amounts of bricks. And what will be the number of amounts of bricks? Number of amounts of bricks would be like 7 minus 2. Okay, so these are the basic ways you are going to use the jump to the current building to the next building. Okay, now just tell me that when my current height building, let's call it as h of I, and my next building's height would, let's call it as h of I plus 1, and if the relation between this and this is going to be like strictly less than, okay, it means that if my current height of the building is of hi and my next building height is of h of I plus 1, and my current heights building is going to be like strictly less than the next heights building, then what should be the optimal way to use bricks or ladders? Okay, now you can see I have to go to the maximum I that we can go using this amount of bricks and this amount of ladders. Okay, so there are some cases, that is if we want to store the difference between this value, that is h of I minus h of I minus 1. Okay, so let us write it down in more clearer way. That is h of I plus 1 minus h of I. That is next building heights minus the current building height. Okay, so because if we want to go to the next building height using either bricks or ladders, I want to make the you store this value difference. That is this is the difference of height that we need to cover up. Either we can cover using bricks or we can cover using ladders. Okay, now if you want to go to maximum I using this bricks and this ladders, what is the most optimal way to use this bricks and this ladders? Okay, so if we want to store this h of I plus 1 minus h of I, what is the difference between this one when my current building height is going to be like less than the next building height? That is when this case occurs, or when this case occurs, or when this case is going to occur, or when this case is going to occur, or when this case is going to occur. Okay, let's try to figure it out what should be the best possible way. Like when we are at this position, that is then my one of the value that I need to store is like 12 minus 4, and 12 minus 4 is going to be 8. That is there is at least, that is there is one position that I need to cover up, and this is going to be like 8. So either we can use one ladder to just cross this one. Yes, we can use one ladder to cross this one. So I can easily reach to this position 12. Okay, so without using any bricks till now. Okay, now let's try to come up to this 12. Yes, we can easily come up to this 12, sorry, this 2. Yes, we can, because 12 is going to be like greater than or equal to 2. Now comes the main thing. Let's try to come up to this 7. Yes, if we try to come up to this 7, I just need to cross, that is I am going to cover from 0 to this 7. I just ask to yourself, can we go from index 0 to this index 3, that is from height 4 to this height 7, by crossing all these buildings in between? Okay, so if you want to do that, then what are the difficult positions that you need to cover up by using bricks and ladders? It should be like using covering this 8 either using bricks or ladders, and covering this 5 that is going from 2 to 7 either using bricks or ladders. Okay, now the one thing that you should keep in mind, that to cover this 8 and to cover this 4, that is one ladder is going to cover as much as amount of height that bricks is not going to do. Okay, in other words, that is suppose the difference is going to be like 100, and we have bricks equal to, let's say, 101. Let me first erase this one. Okay, so okay, if we have bricks as 101 and we have height difference as 100, and we have only one ladder. Okay, and okay, so what is the best way to think for about that? To use all the bricks so that I am exhausted after if further heights come up, or use one ladder to cover this entire height? Okay, so it is always being optimal that using a single ladder if we have the large mud difference. Okay, so it gives me the idea that rather than to uh, work upon the minimum, let's try to work for the maximum ones. That is, if you are at a current index 3, that is you are at this index, and the difficult positions that you need to cover are 8 and 5. Okay, so let's try to cover the maximum differences with the ladders, and if something is going to remain, we will try to cover up using bricks. Okay, so bricks, because ladder is going to cover up maximum height. One ladder can cover up around many as much height that bricks want. That is, if bricks is going to be like some amount A and one ladder can cover up this entire height. And if we use bricks, we can use as much as bricks possible. Okay, so if we want to save my current amount of bricks now, then we can easily cover up the remaining heads. If they come as the difference like that, we will try to cover up using bricks. Okay, so in more formally, you can easily say I'm just trying to cover the difficult positions, that is the differences, maximum differences with the ladders. And if some amount is going to remain, I will try to cover up using bricks, and this is going to be an optimal way. Okay, so you can see I have to cover two positions, 8 and 5, and you can see I have these two ladders enough, so I can cover this entire thing. Okay, now let's try to cover up the this 3. Yes, we can easily go from 7 to 3. Okay, now let's try to come up to this 18. Can we go from 3 to 18? No, we can use a ladder, or we want to use a brick. Okay, so let's try to find out, if we want to go from 0 to this 18, what are the difficult positions that I need to cover up. Okay, so the difficult position that I need to cover up is like 8. Difference of heights I am going to just talking about 8, and when 2 to 7 I need to cover up 5, and going from 3 to 18 I need to cover up 15 height. Okay, the best way to consider that, that is going for the maximum difference, that is 15, I will use the ladder, and then in this case I will use the ladder, and the remaining is going to be like 5. In this case I am going to use the bricks. Okay, this is going to be optimal. Cover the maximum difference with the ladders, and the remaining ones try to cover up using bricks. And if it is possible, yes, it is okay, then go to the next position and try to check the remaining thing. Okay, and yes, it is done, because you can see if bricks is 10, I just need 5. Yes, it is done, so I can easily come up to 18. And can I go to 20? What is the difference? Difference is coming out to be 2. So my one more thing that should be added is like 2. So let's try to cover up. So we can use the maximum 15 for one ladder, and then 8 for one again ladder. Now ladders are going to be exhausted. Let's try to cover up the remaining ones with bricks if it is possible. Yes, it is okay. I'm going to just move to the next. Otherwise, let's stop this one. That is for maximum index I, that I can go with a given amount of bricks and ladders if the differences are going to be like odd. That is hfi plus and minus hfi is going to be like positive value, greater than, yes, positive value. Okay, so I can cover up 15 with one ladder, 8 with one ladder, and ladders are going to be exhausted, that I've already used two ladders. Now come using the bricks. Okay, 5, yes, we can use 5 bricks and 2 bricks, and total number of bricks used is 7, and we have 10 bricks. Yes, I can come up to 20 also. So can I come up to this value 3? Okay, yes, I can come up to this to this 3 value. That is height of building is 3, 20 to 3, because difference is going to be like 20 minus 3 is going to be like positive, and this height is 20 is going to be like greater than or equal to 3. Okay, now let's try to come from 3 to 19. Can I go from 3 to 19? If I try to come from 0 up to this 19 using bricks and ladders optimally, let's try to do that. Okay, so let me first erase this one, and this is going to be like one of the good examples. Okay, so you can see the difference of heights is coming like 4 and 12, it should coming out like to be 8, and 2 and 7 it is coming like to be 5, and again you can see 3 and 18 it is coming like to be 15, and 3 and 19 it is coming like to be 16. Okay, now the if you are using your mind, or if you are trying to solve this problem optimally, the most thing you want to do is try to minimize bricks, so that to save for future, to cover up the distances, and try to use ladders for maximum ones. Okay, so I'm going to just use ladder for this one, and then this one. Now ladders are exhausted. Let's try to cover up the remaining distances with the bricks. Can I cover up? Now you can see 8 can be covered up, but what about 5? It cannot be covered up. The difference is coming out to be 13. That is, sum is going to coming out to be 13, and we had only 10 bricks, so we cannot cover up. Okay, now so now it means that we are not going to, that is, we cannot come to this index I having the height is equal to the 19. So what is the maximum index I that we can come with the given bricks and ladders? It is coming out to be 3. That is the height with index with the height equal to 3. That is at this position. So our answer will be the index of this position, and I am going to use the zero based indexing. Okay, so this is going to be the entire approach. Okay, so what should be the best way to implement this entire scenario? So you can see I can implement this entire scenario, that is to find out the maximum sum, first ladders amount of maximum sum. So let's call it as x. We have x ladders. So we need to find the, you can see we need to find the first x maximum sum, and we have this total sum, and total sum of what? Total sum of such differences, such values which satisfy the relation h of I is going to be like less than h of I plus 1. That is, either we are going to use the bricks or we are going to use the ladders. In such case, I am going to find out the difference h of I plus 1 minus h of I, and for all such values I am just going to find out what is the first x maximum sums. So in this case, you can see 8, 5, 15 and 16. I am going to just find out what is the first two maximum sums. You can see 16 and 15. This can be covered up using ladder. What is the remaining sum? Remaining sum would be like total sum of this one minus this one. You can see the total sum is going to be like 16 minus 15. It is coming like to be 30. That is total sum is like 16, 15, 31 plus 8 plus 5. It is going to be like 44, I think. Yes. So, and what is the first two maximum sums? Like 16 and 15. It is coming like to be 31. So 43 minus 31, it is coming like to be like I think 13, I think. So I think 44 minus 31, it should be like 13. Yes, 8 plus 5, 13. So if 13 is going to be covered with the bricks or not, I am going to check at every time, that is at every time this entire process. That is, first x amount of maximum sums is going to be like max sum and total sum. Total sum minus max sum must be covered with the bricks. If it is covered, yes, it is okay. Go with the next index. Otherwise, just stop iterating for this. Stop iterating, and just we can claim that our answer is the maximum index I, that is the current index. Okay, so if you're not going to understand this, no need to worry about. I'm going to explain this entire thing in the coding part also. Okay, so let's move further. Okay, so let's talk about how I'm going to implement this entire approach. Okay, so my answer is be like minimum index, or I think maximum index. Yes, it is maximum index. So maximum index is now 0, and total sum is going to be like 0 now. Maximum sum, that is first ladder's amount of maximum sum, is going to be like 0. Note that I'm going to use long. Okay, the reason behind this is you can easily see that you can see the constraints, that is heights of I is going to be like 10 power 6 and heights length is going to be like 10 power 5. So in worst case it go up to 10 power 11, so it won't fit into I think int max, so I need to take long. So I am going to use a multiset. You can also use a priority queue to store the maximum amount, maximum first ladder's amount of maximum differences if it exists. Okay. So this is going to use the store. Note that I'm going to use the multiset because I need to store the multiple entries also. There might exist like 5 and 5. If I'm going to use set, it will only store the distinct. So how I can maintain the size? Okay, so I need to take care of the size of also. So I need to first find out the ladder's amount of maximum differences at any time. Okay, so I'm going to use the multiset. Okay, so let's try to understand that. Okay, so for I into I 1, I'm going to start from 1 and it goes up to the end of this heights array, and for now I'm going to just find out if heights of I is going to be like less than the previous height, that is the previous height of the building is going to be like greater than or equal to my current height, then I can easily jump without using either bricks or ladders. Okay, so my answer would become I and continue. That is, yes, we can come up to this state. Okay, otherwise let's find out the difference, heights of I minus heights of I minus 1, the value, and if that value is going to be like less than the ladder, that is we need to find the first maximum sum. That is, yes, it can be covered with the ladders also, because the store dot size is going to be like less than ladders, and I can cover up with the ladders only, no need to use bricks now. Then I can store the maximum sum plus equals difference, and that value is going to be inserted into this multiset. Okay, now think about the case that we have the elements like already covered up in the ladders, that is already we have x amount of differences. That is, I am going to say if I am at this position, okay, if I am at this position 19, then what are the differences? 4 minus 12 8, and 2 minus 7 5, and 3 minus 18 16, and 3 minus 19, I'm taking the absolute value. Okay, so it should be like okay, previous one would be like 15 and it should be like 16. You can see I need two ladders. That is, I need two maximum values. I've already covered 16, I've already covered 15, and in this case, that is, in this case, I'm just coming out in the else part. Okay, so now I'm going to check if store dot empty is going to be like, if store is not going to be empty, multiset is non-empty, and check if difference, that is what is my current value that came up. You can see my current value that came up is going to be like 16. So in the previous case, I have the multiset as this one. So my, if I'm using multiset, the values are going to be like 5, 8, and then 15. Okay. Now this 16 has come up now. Okay. So I'm going to check if the store is going to be like non-empty, and my current difference 16 is going to be like greater than my minimum value in this multiset. Minimum value in this multiset is going to be like 5, I think. Yes, 5. So it means that if I want to store the first ladder's amount of maximum value, then 16 would come in the multiset. Okay, so I just need to pop this element 5 out and bring 16 back in this multiset. Okay, so just I'm going to subtract this maximum sum, that is subtract max sum, subtract the value, minimum value in the multiset from this maximum, and just erase that entry also, store dot erase store dot begin, and insert my current value, that is 16 is going to be inserted, and just increment our maximum, because you just need to take care that I'm just getting the sum first ladder's amount of this max sum. Okay, note that if else part will come only and only when store dot size is going to be like less than ladders, that is I need some breaks now. Okay, and also you can easily see that I just need to find it out the first ladder's amount of maximum, and if we have already reached this ladder's amount of maximum, and if some new element comes, I just need to take care about that this element can be inserted into the multiset or cannot be inserted into the multiset. In that case, we just need to modify my max sum. Okay, and total sum will be always like total sum plus equal to differences, that is the total sum. And if any case, if bricks is going to be like not sufficient to cover up this value total sum minus maximum, and in this case you can easily see 44 minus this first two amount of maximum sum, that is 16 and 15, is going to be like 31, and the difference is coming like to be 13. And if it is 13 and I need the bricks of only 10, that is I need 13 amount of bricks and there are only 10 bricks present, I cannot cover up this one. Okay, so I am going to just else break and return the answer, otherwise my answer would be like I, that is yes, I can come up to this index I. Okay, so let's try to submit this code and check it out if this is going to be a good solution or not. Yes, it is good. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.